Today we're doing section 4.1, day 1, and we're going to discuss how to convert between radians and degrees. So this should be a relatively quick lesson because this is something you learn in Algebra 2. So in Algebra 2 I kind of give you informal definition of a radian. Now we're going to kind of discuss the formal definition of a radian. So a radian is the angle formed in which the enclosed arc is the same measure as the radius. So it's kind of easier to draw a picture for this definition. So imagine we have our circle and we have a radius. So the red line would signify my radius r. And if I were to pick up that red line and draw it on the arc and then enclose the angle that I just created, all of these three measurements would all have the same distance of an r. This angle that is formed right here is what we call 1 radian. Okay, so a little bit different than the concept of a degree, but I think a picture kind of helps with that definition. So radian measure, so then we kind of determine, well, if this is 1 radian, how many radians is in a circle? So again, we're going to kind of visualize a circle, and you know, oh, that's a terrible circle, sorry. You know the circumference is the distance around a circle, which is 2 pi r, and we discussed that the enclosed arc has to be the same measure. So if I go the whole distance around the circle and I take out that radius, this idea of 2 pi is how many radians in one circle. So we can determine that 2 pi is equal to 360 degrees. So getting into some conversions that you're going to have to know. To go from radians, we're going to times by 180 degrees divided by pi. If you're in degrees, you're timesing by pi over 180. And that's how we're going to be able to convert back and forth between these two forms. So getting into some examples. So for these three, we are in degrees going to radians. So for all of these, we're going to be multiplying by pi over 180. So if I multiply this by pi over 180, if I'm doing this without a calculator, as far as reducing, I know the zeros cancel, and now I'm working with 3 over 18, which will cross out to be 1 over 6. So I would say that this answer is pi over 6. If you're using a calculator, you could type 3 over 18, math, enter, enter. Don't ever put the pi in it. We're trying to reduce the fraction. Pi is supposed to be in our answer, not multiplied in. Okay, so again, we're multiplying by pi over 180. The zeros cancel. 9 over 18 is 1/2. So pi over 2 is the equivalent in 90 degrees. And this should kind of make sense because we said, so a full circle is 2 pi, which means a half a circle is pi, and a quarter of a circle is a half of a pi, and there's your 90 degrees to kind of tie that together. All right, and then lastly, we're timesing by pi over 180. So this one's not as easy to do without a calculator. You'd have to, divide by 5 or keep going until you can divide it, or you can use the calculator. When you do it, it reduces to be negative 3 pi over 4. So now we're going to go the other way. So now we're multiplying by 180 over pi. Okay, way I always remembered it when I was in high school, if the pi is in the numerator, when you multiply, you need to put pi in the denominator to make the pi's cancel. 180 divided by 3 leaves me with 60 degrees. Over here, 180 divided by pi, the pi's cancel. So I'm going to go out of order. I'm going to do this part first. So I have negative 5, 180 divided by 3 is 60. and then negative 5 times 60 is negative 300 degrees. All right, that's all for today.